At about 6:30 in the evening on September 18, 1980, an Air Force maintenance crew was working underground in rural Arkansas. Above them were fields, roads, houses, and a small town called Damascus. Below them stood one of the most destructive weapons ever placed on American soil. And then somebody dropped a socket. It fell down the missile silo for roughly 80 feet. There was nothing anyone could do but watch it disappear. The socket struck part of the structure, bounced, and hit the missile itself. The metal skin of the rocket was never designed to stop a heavy tool falling that far. It punched through the first stage fuel tank. A tiny hole appeared in a missile more than 100 feet tall. And from that moment on, everyone at Launch Complex 374-7 was working against the clock. The missile was a Titan II. It stood 103 feet tall, weighed roughly 330,000 pounds, and could reach targets thousands of miles away. Buried beneath Arkansas was a W-53 thermonuclear warhead with a yield of 9 megatons. 9 megatons. This was not a bomb sitting in storage waiting to be assembled. The missile was operational. During the Cold War, 18 Titan II missiles were deployed around Little Rock Air Force Base, with others in Arizona and Kansas. They were part of the American nuclear force, designed to survive an enemy attack and launch quickly if ordered. That ability to launch quickly came with a dangerous advantage. Unlike earlier missiles that had to be fueled shortly before launch, the Titan II stored its liquid propellants inside the rocket while it sat on alert. Its fuel included Aerozine 50. Its oxidizer was nitrogen tetroxide. These were hypergolic propellants. Put them together, and they do not need a match. They ignite on contact. That was useful if you wanted a missile capable of launching rapidly during a nuclear war. It was considerably less comforting when one of the tanks had just been punctured. The socket had opened the first stage fuel tank, and fuel began escaping into the silo. At first, there had been one simple mechanical accident. Now there was a leaking intercontinental ballistic missile sitting underground with another tank of oxidizer above it, and a nuclear warhead at the top. The problem was not that the nuclear weapon was suddenly going to explode like a conventional bomb. The immediate danger was the missile itself. If the damaged first stage lost enough pressure or structural strength, the enormous rocket could collapse inside the silo. If the fuel and oxidizer mixed, the propellants could ignite violently. And nobody could simply walk down, put a patch over the hole, and call it a night. The environment around the missile was becoming toxic and increasingly dangerous. By about 9 o'clock, the Air Force personnel normally stationed at the complex had been evacuated. About an hour later, security police began moving civilians away from the surrounding area, as commanders tried to determine exactly what was happening underground. And that created another problem. The people who understood the missile best were now outside the missile complex. The Titan II did not sit inside an ordinary warehouse. It was protected by layers of security, reinforced doors, underground passages, steel, and concrete. The entire facility had been designed to keep unwanted people out and protect the missile from attack. Now the Air Force desperately needed to get people back in. Airman Rex Huckel and Greg Devlin were sent toward the complex. Normally, crews could use the facility's systems to gain access, but the complex had been evacuated. The two men were ordered to cut through the security fence and force their way through the outer portal. Think about the absurdity of that scene. This was one of the most heavily protected weapons in America, and the United States Air Force was effectively breaking into its own nuclear missile site with hand tools because the emergency had made the normal access system unusable. Huckel and Devlin got through the fence and the outer portal, but they could not open the inner blast doors. Meanwhile, the missile continued leaking. Hours had now passed since the socket fell. Nothing dramatic had happened yet, and that may have been the most dangerous part, because every quiet minute created the impression that maybe the situation could still be controlled. Maybe the missile would remain standing. Maybe the vapors could be measured. Maybe specialists could figure out the next step. Maybe they still had time. Early on September 19th, Senior Airman David Livingston and Sergeant Jeff Kennedy entered the complex to take measurements of the fuel vapor concentration. Their readings were not reassuring. The airborne fuel concentration was at the maximum level their equipment could measure. They came back toward the surface. It was around 3 in the morning. Livingston and Kennedy reached the access area and waited for further instructions. For more than 8 hours, the entire disaster had been building from one dropped tool. Then the Titan II exploded. The blast destroyed Launch Complex 374-7. The reinforced launch closure over the silo weighed roughly 740 tons. The explosion threw it about 200 feet into the air and sent it hundreds of feet away from the silo. Concrete, steel, fire, and debris erupted across the facility. Kennedy was blown roughly 150 feet and suffered a broken leg. Livingston was buried among the wreckage. Rescuers eventually found him and got him out, but he died from his injuries later that day. 21 people were injured in the explosion, or the rescue effort that followed. And then came the question that mattered far beyond the missile site. Where was the nuclear warhead? The Titan II itself had been destroyed. Its launch complex had been ripped apart. The missile had exploded beneath a 9-megaton thermonuclear weapon. Yet there had been no nuclear detonation. The W-53 warhead had been thrown clear of the missile and landed roughly 100 feet from the entrance gate. Its safety systems had done their job. There was no nuclear explosion and no loss of radioactive material. That distinction matters. The Damascus accident is sometimes retold as if a dropped socket nearly caused a 9-megaton nuclear blast in Arkansas. The real story is more interesting than that. A maintenance accident destroyed an operational American nuclear missile, killed an airman, injured 21 people, demolished an enormous hardened launch facility, threw its massive closure into the air, and launched a thermonuclear warhead out of the wreckage. And after all of that, the safeguards inside the nuclear weapon prevented the accident from becoming something even worse. When daylight arrived, the landscape around the silo looked nothing like the quiet Arkansas missile site that had existed the previous afternoon. The complex was ruined. Debris had been scattered across a wide area. Cleanup crews eventually collected material from roughly 400 acres around the site and removed about 100,000 gallons of contaminated water from the silo. The estimated cost of replacing the launch complex exceeded $225 million, while demolition and cleanup were expected to cost another $20 million. The Air Force never rebuilt Launch Complex 374-7. Instead, the remains were ultimately sealed beneath soil, gravel, and concrete debris. The accident also forced uncomfortable questions about a weapon system that had been sitting on alert for years. The Titan II had an extraordinary military purpose. It had to remain ready. It had to survive. It had to launch quickly. That meant keeping an enormous liquid-fueled rocket underground, fully loaded, 24 hours a day. The same characteristics that made it useful as a Cold War weapon also meant that maintenance crews were working around huge quantities of dangerous propellant while a thermonuclear warhead sat above them. And this was not even the first serious incident at this particular complex. In January 1978, Launch Complex 374-7 had suffered an oxidizer leak that produced a toxic cloud and forced civilians from the area. That accident was repaired. The missile site returned to service. 2 years later, a socket fell. After the 1980 disaster, a congressional inquiry concluded that the Titan II program was essentially reliable, but it recommended improvements in communication between the Air Force and local authorities during emergencies. 6 servicemen involved in the response were later awarded Airman's Medals for heroism, including David Livingston posthumously. The Titan II system remained operational for several more years. The last missiles were removed from alert in the 1980s, ending a service life that had begun in the early 1960s. But the destroyed silo in Arkansas left behind one of the strangest lessons of the nuclear age. People often imagine catastrophic weapons failing because of equally catastrophic events. An enemy attack, a computer failure, a massive mechanical breakdown, some complicated chain of events nobody could have predicted. Damascus began with something much smaller. A maintenance worker was performing an ordinary job. A tool came loose. Gravity did the rest. The socket fell 80 feet. It struck one particular place on one particular missile. And 8 hours later, a weapon designed to cross continents had destroyed itself without ever leaving Arkansas. There is something almost impossible to process about the scale difference. On one side was a 103-foot intercontinental ballistic missile carrying one of the most powerful nuclear warheads ever deployed by the United States. On the other was a socket small enough to hold in one hand. The socket won. But that is only half of the story. Because when the missile failed, when the silo failed, when the structure around it was destroyed, and the warhead was thrown out of the wreckage, another layer of engineering still worked. The warhead did not detonate. So the Damascus accident is not simply a story about one mistake nearly ending in catastrophe. It is a story about how complicated systems actually fail. Not all at once. One layer at a time. A tool falls. A tank opens. Fuel escapes. People evacuate. Access becomes difficult. The situation gets worse, while everyone tries to understand it. Then one final failure destroys almost everything around the weapon. Almost everything. Because the last safety systems still matter. And on September 19, 1980, in a field near Damascus, Arkansas, they mattered more than anyone would ever want to test.